So Wednesday in class, we talked about everything arithmetic sequence and all the things that we could do with an arithmetic sequence, such as create an explicit formula, make the open version of the explicit formula, make the closed version of the explicit formula. And remember that the open version was the non-simplified, where I knew my first term, it had n minus 1 in it. And then the closed was the simplified version, where I distributed in the common difference and then combined my like terms. We also talked about the recursive formula, where I had a sub n equals a sub n minus 1 plus the difference, and then you could tell me what the first term was. And then we did all types of problems of how to manipulate those different things to find those answers. So today what we're going to discuss is everything geometric. And just as we started with the explicit version for arithmetic, we're going to start with the explicit version for a geometric sequence. So geometric sequence is a sequence that has a common ratio, and that common ratio is going to be called R. If we remember back, arithmetic sequences has a common difference called D, and the difference in those two things are common difference is what we add to get to the next term, common ratio is what we multiply. So common ratio is simply going to be a number or a constant. Okay, remember, a constant is simply a number without a variable that each term in a sequence is going to be multiplied by to find the next term. We talked about even if our numbers are getting smaller and we divide, we can take that number that we divide by and turn it into multiplication by saying that we're multiplying by a fraction. So for instance, if in a sequence I'm dividing by 4, I can write that as a common ratio of multiplying by saying I multiply by 1/4. You take the number that you divide by, you make it the denominator, you put 1 over it in the numerator, and that is the common ratio that you multiply by. So to determine the common ratio, we want to divide the second term by the first term. So just like in an arithmetic sequence, how I told you to subtract the second one, the first one from the second, so it'd be A2 minus A1, A3 minus A2, A4 minus A3. We're going to do the same thing here, except for we're going to be dividing, because the opposite of multiplying is dividing. So if I have A2, I can divide it by A1, and I can continue this to be A3 divided by A2, and then A4 divided by A3, and so forth, where if I have A sub n, I would divide it by A sub n minus 1, the previous term. So let's look at these examples. Determine if the sequence is geometric, and if it is, find the common ratio. So if I'm going to practice what we just talked about, I would take -6 and divide it by -2. So the second term divided by the first term. And that's going to give me a value of +3. Okay. Then I'll take the third term, -18, and I'll divide it by the second term, -6. Well, -18 divided by -6 gives me +3. Take the fourth term, -54, divide it by the third term, -18, and I get +3. Remember, we have to have a common ratio. Since all of those numbers that we divided are the same, it is geometric, and it has a common ratio of +3. As we get ready to do number 2, we take -24, we divide it by 4. That gives me -6. Then we'll take 144 and divide it by -24. Again, we can take this to the calculator if this doesn't pop out easily to you, and I get -6. Then I'll take -864 and divide it by +144, where I get my answer to be -6. All these values are the same, so my common ratio is -6, and it is a geometric sequence. For example 3, we're going to take the second term, which is 1/3, divide it by 1, where we get 1/3. We take the second term, the third term, 1/9, divide it by the first term. Now, if you're watching this video and this is going too quick, remember you have a pause button, so you can pause, work this out on your own, and then check your work with what I'm doing if you need to. So when I take 1/9 divided by 1/3, I get 1/3. When I take 1/27, which is my fourth term, and I divide it by the third of 1/9, I also get 1/3. I notice that all those values are the same, so my common ratio is 1/3, and this is a geometric sequence. This is just another way of testing, is it geometric? When I get to number 4, I'm going to take -6 and divide it by -14. And when I do that, I get a simplified fraction of 3/7. Then I'll take -2 and divide by -6, where I'll get 1/3. Then I'll take 0 and divide it by -2, which equals 0. Now notice that all my values are different here, so it's not a common ratio. So for this one, there would be no R value, and we would just say that it is not geometric. So now that we know how to test our values to find the common ratio, we need to practice creating the explicit formula. Now, again, this explicit formula will be given to you on the test. It's on the formula sheet, so you don't have to worry about memorizing it. And the good news for the geometric sequences are there's no open and closed. There's no way to distribute here because it is already in simplified form. A sub n will be the value of the term number n. A1 is always our first term. R is the common ratio, where n is the term number. So what place did it come in? First, second, third, etc. Right? In order to write an explicit formula, these are the rules that we'll follow. First, we want to determine what the first term is going to be. So we just look at our list, or look at what's given, and we can determine the first term. Then we'll want to determine the common ratio. So what did I multiply every time by? And again, it'll be denoted by R equals. And you can find this by plugging in your A2 divided by A1, A3 divided by A2, A4 divided by A3. And then we want to fill it in to the formula, where we know that it's A1 times the common ratio to the power of n minus 1. Make sure you know that n minus 1 here is an exponent. So as we practice the examples here for number 5, we're going to be given the first term and the common ratio. They want us to write the explicit formula. Well, my first term is 0.8. My common ratio is 5. It goes inside the parentheses. And because it's the explicit formula, it's to the power of n minus 1. For number 6, my first term is 4. My common ratio is 4/5, and it's to the power of n minus 1. So we're going to build on to this. Not only are we going to write the explicit formula, but now we're going to find the specific term that it's asking us for. So A1, which is -2, times the common ratio of -6, and that's going to be to the power of n minus 1. So to find the 8th term here, I simply see that 8 has replaced the n. So I say -2 times -6 to the 8 minus 1 power. And all you have to do is type that into the calculator. Remember that 8 minus 1 is going to be an exponent. And you should get 559,872. As you're getting ready to do number 8, first term is 5, common ratio of -1/2, and that is to the power of n minus 1. I'm going to plug in 9 for n. You can see that's what I'm replacing. 5 to the negative 1/2, I'm sorry, 5 times negative 1/2 to the 9 minus 1 power. And if you need some extra time to put this into the calculator, remember to pause your video, type it in, and see if you get the same answer that I do. And when you type it into your calculator, you get 5 over 256. Now, if you have this in decimal form, that's fine. 5 divided by 256 would give me 0.0195. The next set, they don't want us to have to plug in anymore. All they want us to do is to create the explicit formula. Well, when we create the explicit formula, I need to check what my common ratio is first. So I'm going to take negative 6 and divide it by 2, where I get negative 3. I'll take 18, divide it by negative 6, and I'll get negative 3. And then I'll take negative 54 and divide it by 18, where I also get negative 3. So my common ratio is negative 3. To create my formula, my first term was 2. So 2 times negative 3 to the n minus 1 power. All right, for number 10, I need to first find my common ratio. So negative 2 divided by negative 4, where I get 1/2. Negative 1 divided by negative 2, 1/2. Negative 1/2 divided by negative 1, where I get 1/2. So my common ratio here is positive 1/2. My first term, negative 4. Multiply it by the common ratio 1/2, and it's to the n minus 1 power. For example 11, first find the common ratio. So again, I can do 6 divided by 2, which equals 3. 18 divided by 6, which equals 3. 54 divided by 18, which equals 3. So I know that my common ratio is 3. My first term is 2 times the common ratio of 3 to the n minus 1 power. Then as I'm getting ready to solve, I'm finding the 8th term, so 8 replaces the n. So 2 times 3 to the 8 minus 1 power. And when you type this into your calculator, you should get 4,374. We're getting ready to do number 12 here. Well, I've got negative 12 divided by 3, which is negative 4. 48 divided by negative 12, which is negative 4. And negative 1,900, negative 192 divided by 48, which gives me negative 4. My first term is 3 times negative 4 to the n minus 1 power. And I'm finding the 8th term again, so 3 times negative 4 to the 8 minus 1 power. That's going to give me negative 49,152. All right, so that's everything we could do with an explicit geometric sequence. Now we're going to move into the recursive formula. So another form for geometric sequence is called the recursive formula. And again, this one will also be provided for you on the formula sheet. This formula will be useful when finding the next term. As we look at these formulas that are given, just like we talked about on Wednesday, there's some parts that never change. A sub n equals a sub n minus 1. And then my a1, so my first value equals what? The two parts that will be changing here are the value that I multiply by, first of all, and whatever the first term equals. So just like in our notes that we've taken over and over again, a sub n represents the value of term n. A sub n minus 1 represents the previous term. R represents the common ratio. And A1 represents the first term. Again, all these things we've talked about multiple times, just making sure that you know exactly what each part of this recursive formula means. In order to write a recursive formula for a geometric sequence, first we want to determine that the sequence is truly geometric. So multiplying to find the next term. Then you want to identify the common ratio. Remember, what is that number that you multiplied by? Then you want to create a recursive formula using the common ratio and stating, we're going to use the common ratio and the previous term, so my a sub n minus 1. Then we also want to state what our first term is. Again, things that never change. So let's practice. Okay, so when we write the recursive formula, we must include the first term. This is what people forget the most. And again, I like to start with the first term because it's the easiest thing to identify. What is my first term in this sequence? -2. I don't forget. Then you ask yourself, what I do to -2 to get to 8? And if you don't want to have to think about it, you just take -8 and you divide it by, if you take 8 and you divide it by -2, which gives me -4. Then I could take -32 and divide by 8, which gives me -4. And 128 divided by -32, which would give me -4. So as I get ready to write the other part of my recursive formula, a sub n equals a sub n minus 1, and then what did I multiply by? -4. Okay, as we look at number 14, we have 9, 12, 16, etc. My first term is 9. When I'm getting ready to find the common ratio, you might be a little confused here. You just want to do 12 divided by 9. And when you do that, you get 4/3. Then you'll do 16 divided by 12, and you get 4/3. So my common ratio is 4/3, or you could put 1.33. As I get ready to write my formula, a sub n equals, the part that never changes, a sub n minus 1. It is a geometric recursive, so I am multiplying by my common ratio of 4/3. All right, for 15, we're doing the same exact thing. If I need to be able to first identify my first term, which is 81. If I need to find my common ratio, you can take 81, divide by 27, where I get, I'm sorry, I did that backwards. My first term is still going to be 81, but remember it's A2 divided by A1, so 27 over 81, which gives me 1/3. Then I've got 9 over 27, which tells me 1/3, and 3 over 9, which equals 1/3. So my common ratio is 1/3. The part that will never change, a sub n equals a sub n minus 1, and I am multiplying in this case by 1/3. For number 16, my first term is 1/2. I have to find what my common ratio is. So I'm going to do 2 divided by 1/2, which should give me 4. I'll do 8 divided by 2, which equals 4, and 32 divided by 8, which equals 4. So now write my the first part of my recursive formula, a sub n minus 1, the part that never changes, is going to be multiplied by my common ratio of 4, which is what I found here. As we move to examples 17 through 20, they're going to give us the formula. They want us to find the first 5 terms. Well, my first term is listed, so it is 5, and I can tell what I'm doing to my numbers right here. So I'm multiplying by 3. 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is 135. And 135 times 3 is 405. And again, this is calculator work. For number 18, my first term is 2. And I know that I'm multiplying everything by negative 6. So negative 12, positive 72. Remember, my R value is negative, so my sign should be alternating. Negative 432. And 2,592. For number 19, my first term is negative 64. And I'm multiplying that by half. So really, if you want to think about it, I'm dividing it by 2. So negative 64 times 1/2 gives me negative 32. Times 1/2 gives me negative 16. Times 1/2 gives me negative 8. Times 1/2 gives me negative 4. And then for this last one, my first term is 243. I know that I'm multiplying these values each time by negative 2/3. So if I do that, my next term will be negative 162 times negative 2/3, which gives me 108, times negative 2/3, which gives me negative 72, times negative 2/3, which will give me positive 48. Again, all this is calculator work. Next little section should be fairly easy for us. They've given me the first term and what the common ratio is. They just want me to make the recursive formula. So the part that never changes, a sub n equals a sub n minus 1. We're going to multiply that, in this case, by 6. And my first term is 5. For number 22, the part that never changes, a sub n equals a sub n minus 1. It's geometric, so I'm multiplying this by negative 9. It's identified here. And my first term is negative 2. For 23, part that never changes, a sub n equals a sub n minus 1 times negative 1/6. That's my common ratio. My first term is 2/3. For 24, a sub n equals a sub n minus 1 times 3. And my first term is negative 5. All right, the last little bit, last section. Given the explicit formula for geometric sequence, find the recursive formula. So we just need to be able to identify the parts. We always start with a sub n equals a sub n minus 1. Well, in the explicit formula, I can tell that my R value is always found inside the parentheses, and that was 8. And then I know that my first term is outside the parentheses, which is 2. For 26, part that never changes, a sub n equals a sub n minus 1. What number is inside the parentheses? And that's negative 1/2. That's my common ratio. And my first term is the number on the outside of the parentheses, which is 6. For 27, part that never changes, a sub n equals a sub n minus 1. Number inside the parentheses doesn't change, it is 2. That's what I'm multiplying by every time. My first term is 3. For 28, a sub n equals a sub n minus 1. Part that never changes. My common ratio is 1/2. And my first term is negative 6.